Hello everyone, welcome back. Hope you're all doing good. So this is continuation to the linear programming introduction that we had. So as part of the chapter 12 linear programming, part of exercise 12.1, we will have a couple of questions discussed in detail. So you'll get better understanding to start with linear programming problem solving method. Okay, and as I said earlier, so we need to read the question carefully and then understand what are the different constraints that is part of the question. So these are the limitations or the limiting factors that we have as part of this question. And we have objective functions. So this is the equation that we need to consider, and there are some variables that are being given, and we need to find out the maximum value that we can get here. So if the question has got maximize, we need to find out the maximum value. So you need to carefully understand whether they are asking about minimize or maximize. Okay, so we need to find the maximum value out of this particular calculation. So as I explained earlier, there are certain terms that we need to be familiar with. So these are the terms that we talked about. See, for example, in this question, so the objective function is z is equal to 3x plus 4y, and there are two different variables in this. And what is the constraint that we have got? So there are three different constraints: x plus y less than or equal to 4, x is greater than or equal to 0, y is greater than or equal to 1. So that means if x is greater than or equal to 0, if y is greater than or equal to 0, so if it is on the positive side, then your answer should be definitely on the first quadrant. So first quadrant is nothing but this is the one which is called first quadrant, and this is second quadrant, and the bottom one is third and fourth, right? So this is the second quadrant, right? And this is the third one, and this is the fourth one, right? And if x is greater than or equal to 0, and if y is greater than or equal to 0, then the value should form, I mean, the answer will be under this particular area, the optimal solution, right? We will get to find that quickly. Okay, as part of this calculation, first we need to understand and calculate the variables, the x and y, and once we have the values for x and y, we can apply that in the constraint formula, and we can derive the vertices or the corner points, and from which we will be able to derive the z value. So see, the reason I've got a couple of tables put together in advance, so this is how you have to derive the solution. So if you are having a very detailed, neat tabular format where you can go and fill in the information, see if the person who is correcting your paper, if they find correct answers around this particular table and the graph, and maybe if you have made some mistakes in the calculation below, so at least you will get portion of the marks. If you're just going with your own way of writing and completing the entire thing, then you might not get, or you might not get partial score also. So let's try to understand, and let's try to solve these two problems quickly. Okay, so let's go and understand what they have given as a constraint. So x plus y is less than or equal to 4, right? So let's say x is x plus y. Let's assume x plus y is equal to 4 here. Okay, so let's go and assume that x plus y is equal to 4. And so what we need to do is we need to have a couple of conditions put here. So let's say if x is equal to 0, what happens if x is equal to 0? So let's apply that. So if x is equal to 0 in this above formula, so what will happen? So let's try to write it out. So 0 plus y is equal to 4. Okay, we are substituting x by 0 here in this particular formula, right? And then what happens? So when the 0 goes this side, it will be 4 minus 0. So the answer that we have got is y is equal to 4, right? So if we have 0 as the value for x, then the value that you are getting for y is 4. Similarly, we will assume that if y is equal to 0, what will be the value for x? That is what we are going to find now. So in place of y, we need to have 0. So x is equal to 4 minus 0. Then that means x is equal to 4 if we have y as 0. So this looks to be a very straightforward problem. So we are able to identify. So in general, we will have three different vertices or three different corner points. So we'll have 0, 0. So we have assumed that x is equal to 0 and y is equal to 0. So let's take this is one of the corner point. And what are the other corner points we have got? X comma y is equal to 0 comma 4 here. And then in this one, we have got again 4 comma 0. So let's go and have this marked in our graph here. So first one is 0 comma 4. So x is 0, y is 4. Similarly, we have got y is 4, x is 4, and then y is equal to 0. So this is x and y is equal to 0. So we have got 3 corner points now. So let's go and have the lines laid out here. Let me just go and connect these 2 dots. Okay. So if I connect these 2 dots, so let's now understand the constraint here. See, this is the answer that we have got for the question x plus y is less than or equal to 4. So then that means if it is less than or equal to, the answer will be around this side. So below this particular line. So this linear answer that you got. So this is the linear programming, right? So we will generally get a line, and x is actually greater than 0. It should be above this, and y is also greater than 0. So the answer will be somewhere within this area. So this is the 3 corner points, or this is the feasible area for our question or for our problem here. So this way we have find out the 3 different corner points for our calculation. Now let's move on to find out the value of z here. So let's write down the 3 vertex here. So what are the 3 corner points? So we have got one corner point which is 0 comma 0 for O, and then we have got 0 comma 4, x is 0, y is 4 in this particular, let's call it as A, vertex A, and let's call this as vertex B. So this will be 4 comma 0. So let's go and write all these 3 vertex or corner points in our formula. Okay, so vertex O is 0 comma 0, and then vertex A is 0 comma 4. You can also interchangeably write, that shouldn't be a problem. Okay, so 4 comma 0. When I say interchangeably write it, so you can name this as A and then name the other one as B. That shouldn't be a problem. So now we have the calculation formula which we need to use here. So the formula is z is equal to 3x plus 4y. So this is the formula that we have got for this calculation, right? So let's go and use that formula for calculating the answer here. Right, let me just write it. So here if we substitute x and y with 0, so it will be 3 of 0 and 4 of 0. Anything multiplied by 0 will be 0. So 0 plus 0 is equal to 0. So the value for the z is 0 in the first vertex. So for the second one, it will be 3 of 0. We are substituting the numbers here for the x and y values that you have got here. So this is x, this is y. So I've just substituted the values in this particular formula. So it will be 3 plus 4 4s are 16, and this will be 0. Anything multiplied by 0 is 0, and it is 0 plus 16. The answer is 16. So here we will substitute the x by 4, and the y will be substituted by 0. So 3 4s are 12, and 4 times 0, anything multiplied 0 is 0. So the answer is 12 here, right? So we have got 12. So what is the question here? We need to find out the maximum value here, the maximize. So that means, so answer here is 16 will be the maximum one, right? And then the vertex, the quadrant that is related to the corner point is 0 comma 4, right? That is the corner point for this 0 for this maximum value. So let's go and write the answer here. So the answer or the solution will be maximum value is 16 at the corner point 0 comma 4. So this is what they will look at. Now while finding this, we also got a couple of answers derived for x and y, and also we have got the graph and all those things, right? So that way, like, we will get portion of the mark if you are making some mistakes. Like I made a mistake here, right? Three times zero, anything multiplied by zero, it has to be zero, but I mistakenly wrote the three. So if you are making mistake somewhere here, so see, the answer will be 19 in that case, right? But the vertex will be correct, x and y will be correct, so you will get very portion of the mark there. So let's try to focus and then don't make mistake. Try to practice yourself. The more you practice, the mistakes will be very, very less, or the mistakes will be zero. So let's go on to the second example, second question. So we'll have the same approach for this particular question. So there is an objective function. So the optimization that we are looking at here is to minimize and find out the value. And there are 4 different constraints here. So that means there are multiple corner points we might get. Maybe a maximum of 4 corner points might be there in this particular question. So let's move on and complete this. So we will just fill this point here. This will be O, or you can call it a 0, whatever you want to name it. And now, so this is all x-axis and y-axis. That should be, this is y, and the below one will be y dash. So that is something which everyone knows, right? So this is x and y axis. Okay, and the left one is x dash, and this will be y dash. So now let's go and substitute 0 for x and y, and then let's try to find out what is the outcome we get. So here there are 2 different constraints. Okay, so that means we might have to okay, it will be just, there are 2 constraints, constraint number 1 and constraint number 2. So in the formula we might have to use both of them and find out the xy value. So that way you can put together the graph. Okay, let's go and find out the values here. So in this particular formula, let's go and say, well, let's assume that x plus, sorry, just give me a second. Okay, so let's go and solve this problem. Let's assume that x plus 2y is equal to 8. So that is what we have got in the formula, right? And then there is one more formula, 3x plus 2y is equal to 12, right? Generally, when we calculate the x and y values, we need to change this less than or greater than or equal to by the actual equal to here, and then put the number. So now let's substitute the value for x is, okay, before we go and substitute that, we need to find out 2 different steps here, right? In this particular calculation, in the earlier one, it was just one set or one constraint where we were finding it out, but this time it will be 2 different constraint where we need to substitute 0 and find out the values. So now let's go and substitute 0 here, right? When I substitute 0 for x, and let's try to find out the y value here. So here it will be 2y is equal to 8 minus 0, y is equal to 8 by 2, and y value is equal to 4, right? So that is what we have got here. So when we are trying x is 0, y value is 4. Let's try to put the value for y as 0 and then find out what we get. So x plus 2 of 0 is equal to 8, and then x plus 0, anything multiplied by 0 is 0. X is equal to 8 minus 0, which is 8, right? So we have got 8 here. Now let's go and calculate the x and y value in the second, using the second constraint, right? So here we will have 0 here for x, and then let's find out the y value. So 0 plus 2y is equal to 12. So y is equal to 12 by 2. So if you move this 0 here, it will be 12 minus 0. Again, it is 12. So y is equal to 6. Okay. So 6. Now let's substitute 0 for y in this formula and then find out 3x plus 2 of 0 is equal to 12. 3x plus 0 is equal to 12. 3x is equal to 12 minus 0, and we'll get 3x is equal to 12. X is equal to 12 by 3. X is equal to 4, right? So we have got 4 for this particular thing. So now we have got multiple quadrant. So we have got a quadrant of 0, 8, and then we have got, sorry, not 0, 8, it is 0, 4. And then we have got, just a second. So it is 0, 4, x is 0, y is 4, and then x is 8, y is 0, and then the default is 0, 0 is the default quadrant, which we have used for the calculation. X is 0 and y is 0. So now here also you have got 0, 6, and then x and y is 4, 0. There are 4 different quadrants. Let's go and mark this quadrants or the corner point in the diagram. So it is x0 and then y4. So which means this will be one of the point, x0 and y4. So maybe let's try to use a different color so that, so this is one corner point, x0 and y4. And then we have got 8, 0. So 8, 0 will be here somewhere. So we have got 7 and we have got 8. And now, what are the other corner points? So we have marked 0, 4, and we have marked 8, 0. So these things were marked. Now we need to mark the 0, 6. So 0 is x and y is 6. Okay, and then we have got 4, 0. So x is 4, y is 0. So now let's mark these two lines, and then we have to mark these two lines and then find out what we get. So let's bring the lines here. Let's go and mark them. So I have to connect this and this one, and then I have to connect this one by this one. Right now, these are the answers we have got for each of the linear. So this constraint, for this constraint, x plus 2y is equal to 8. So this is what we have got. X plus 2y is less than or equal to 8. So that means, so in this formula, so this is for 3x plus 2y is less than or equal to 12. See, if you understand the question properly here, okay, so here they are saying it is less than or equal to. Here it is less than or equal to. So which means the line, the answer will be the feasible region is within this particular boundary. And they have also given other two constraints, x is greater than or equal to 0 and y is also greater than or equal to 0. So that means then the answer is somewhere within this feasible region. So I would mark these 4 corner points, and then this is the bounded one, right? This is the bounded area, and this is one of the corner point. This is one of the corner point. This is one of the corner point already we have marked, and this we can name it. Now we can go and label it as A, B, and then C. So you can name it anyways, like you can also name this as A, B, and C. So using this corner points, we will now go and find out the Z value. So here, so this particular one is somewhere in between, okay, so X is maybe, sorry. So we have this somewhere here. And then somewhere here. So this is where the graph will be much good for this calculation. See, if you have done this in graph, so you might have got a very good state like kind of graph like this. So that's the reason for this particular linear programming calculation, always go with the graph sheet. If you have a graph sheet, so you can have numbers properly aligned, and this way it will be easier to go and say somewhere here, and then it will say we can just get that particular answer very straightforward way. Okay, always use a graph, but here see if in case you're not getting the graph sheet, so anyways you have to deal with the white sheet. So that's the reason I'm explaining it in white sheet. So this quadrant, maybe it looks like it is somewhere around 2, 3, right? This is where we are, and then here I can just map it to 2 x2 and then y3 for the a1, that is x is equal to 0 and then y is equal to 4, and for the C1 x is equal to 4, y is equal to 0. So these are the four different vertex or corner point we have got. We'll go and apply that in our formula, right? So here vertex 0 is 0 comma 0, then vertex A is 0 comma 4. Sorry, let's go and confirm that. Yeah, I think it is 0 comma 4, and then vertex B is 2 comma 3, and then vertex C is, the corner point C is 4 comma 0. So I've just written the value of the corner points here. So the one, this one is 0, and this one is A, and then this one is B, and then this one is C. So now we have to apply this particular corner points in the formula or the objective function that you got. See, whenever you are doing the calculation, so ensure you are not missing the minus there. See, in this particular formula, we have got a minus value, so it is very, very crucial. So we need to be extra careful when we are going to deal with this particular problem. Right? Let's try this. Okay, we'll go and substitute the values here. So instead of x, we are going to have the 0. So anything multiplied by 0 is going to be 0. So that means like 0 plus 0 is equal to 0. And the z value is 0 here. Okay, so for the second problem, let's go and substitute the 0 comma 4 value. So minus 3 times of 0 plus 4 of 4. Then that means anything multiplied by 0 is 0 plus 16. So the answer here is 16. Okay, so now here we will substitute. So it is minus 3 of 2 plus 4 times 3. So minus 3 into 2 is minus 6 plus 12. So which means the answer is 12 minus 6 is 6. Right? We have got value 6 here. So for this formula, it is again minus 3 times 4 plus 4 times of 0. So minus 3 times of 4 is minus 12 plus 0. Answer is minus 12. Right? So this will be minus 12. So here in this question, what they have asked us, they have asked us to find out what is the minimum value. It's not the maximum value. So that is where we need to be very, very careful and answer it properly. So in this answer, the minimum value is minus 12, right? That is what we have got. So that would be the right answer, minus 12. And what is the corner point here? So the corner point here for that vertex C is 4 comma 0. Okay. So now let's go and write it out. So minimum value minimum value is minus 12 at what point? At vertex C, which is at 4 comma 0. Okay, so this is how you need to write the answer. So the answer will be minimum value is this one. See here, if they've asked you to find the feasible region is all these areas, right? So it can be this area, or this corner point, or this corner point, this one. So all these are corner regions, corner points are feasible one. But the answer is they're asking us to find the optimal value, the final, the best one. So the best one is z is equal to minus 12. So this is the value that we have got for the z, which is the minus 12 is the minimum value. Now, sometimes in some of the question, we might have very large numbers. So if you're having very large numbers, so instead of having the graph by 1, 2, and 3, you can just go with 10, 20, and so on. Okay, so that way you have higher numbers covered. So in the question itself, you can see that the x plus y is greater than or less than or equal to 50, and then there is some 90 numbers. So that means your answers are going to be in tens, not ones. Okay, so if your answers are in tens, then the graph should be drawn in 10, 20, 30, and so on in tens, so that you can just go and plot the answer properly and then get it done. So that's a tip actually. So if you are having the feasible region OABC values are coming around higher numbers and the corner points are higher, then the graph will have to be drawn in such a way that you are having tens instead of ones. So you can have that in tens also. That is what you've got for x and y axis here. So thank you for listening, and I hope it was helpful. And yeah, as much as possible for linear programming, using a graph sheet is much advisable. So that way you get a better answer. But it's okay if you don't have a graph sheet. If you practice well, you can go and get the answers right. Thank you.